Welcome to solverfy.
Hi, in the given problem, there is a principal axis, a common principal axis for a convex spherical mirror whose focal length has been given as 50 centimeter and for a convex lens whose focal length has been given as f1 is equal to plus 80 centimeter. The gap between these two is given as 1 meter, or we can say 100 centimeter. Then there is an object in the left side of convex lens at a distance of 100 centimeter. 1 meter means 100 centimeter from the optical center of this convex lens, and this is the pole of the spherical mirror. Now we have to find the positions of various images formed by convex lens, then by spherical convex mirror, and then again by convex lens. So in three parts we will have to deal this problem. So first of all, for convex lens, the object distance will be taken as P1, which is equal to minus 100 centimeter using sign convention. This is 100 centimeter. Focal length f1 of the convex lens is plus 80 centimeter. Then using thin lens formula, which is 1 by q1, where q1 is the distance of image formed by this convex lens from its optical center C. So 1 by q1 minus 1 by p1, which is the object distance, is equal to 1 by f1. So when we put these values here, 1 by q1 is missing, 1 by minus 100 is equal to 1 by 80. So this 1 by q1 comes out to be 1 by 80 minus 1 by 100. If you take LCM of 80 and 100, it comes out to be 400. So here this is 80, 5s are 400, so this is 5, and 100 4s are, so this is 4. So it becomes 1 minus 1 by 400. So finally, the distance of the image formed by this convex lens is 400 centimeter. Having a positive sign means it is towards right side of the lens. Towards right side of the lens means somewhere here at a distance of 400 centimeter. But before that, this spherical mirror, convex spherical mirror, intercept the rays going away from this convex lens. So that image formed by the convex lens will serve as a virtual object for this spherical mirror. So in the next step, we will consider the image formation by convex mirror. So for convex spherical mirror, the object distance will remain this from pole of the mirror to this image. So it will become P2 is equal to positive, as the distances taken in the direction of incident ray are taken as positive. So object distance for this spherical mirror will be positive. So positive 400 minus 100 means 300 centimeter is the object distance for convex spherical mirror. Its focal length has been given as 50 centimeter. So now using mirror formula, which says 1 by P2 plus 1 by Q2. Q2 is the distance of the image formed by convex mirror, is equal to 1 by F2, the focal length of convex mirror. When we put the values, this is 1 by P2 means 1 by 300 plus 1 by Q2 is equal to 1 by 50. So finally this 1 by Q2 comes out to be 1 by 50 minus 1 by 300 is equal to LCM is 300. So here this is 6 minus 1 or 5 by 300, which comes out to be 1 by 60. So finally the distance of image from the convex spherical mirror will be plus 60 centimeter. Here this positive sign shows that the image is still towards the right side of this spherical mirror. Means the image formed by convex mirror is somewhere here at a distance of Q2. Now this image will serve as the object again for the convex lens. So for this, the distance, object distance will become 100 plus 60 centimeter. So in the third step of the problem, for convex lens again, distance P3, distance of object, virtual object from this convex lens will become minus 100 plus 60 centimeter, or we can say this is minus 160 centimeter. The reason behind negative sign is that the rays are moving like this, and the distance we are measuring from the optical center of the lens towards right hand side, while the rays are moving towards left hand side. That's why the distance is taken as negative. And focal length is again f1, which is nothing but 80 centimeter. So using thin lens equation again, we get 1 by Q3 minus 1 by P3 is equal to 1 by F1. Putting the values, 1 by Q3, this is missing, minus 1 by minus 160 centimeter equals to 1 by 80. So finally this 1 by Q3 becomes 1 by 80 minus 1 by 60, or this is LCM is 160. So here this is 2 minus 1 means 1 by 160. So finally the image formed by convex lens again is plus 160 centimeter from the optical center of convex lens towards right hand side of the lens. So these three are the answers for the first part of the problem. Now in the second part of the problem, we have to find the total linear magnification produced by the combination of lens and the mirror, and it will be equal to the product of linear magnifications produced by the lens first of all, m1, then by the mirror, and then again by the lens. So as we know, the expression for linear magnification produced by lens is q1 by p1. For mirror, it becomes negative of q2 by p2, and again for lens, it becomes q3 by p3. So when we put these values here, for q1, that is 400. For p1, this is minus 100 multiplied by negative of q2, which was 60 plus 60, and p2, that was 300. Then for the third situation, for q3 and p3, q3 is 160 and p3 is also 160 of positive sign. So finally here it is, but q3 was minus 160 for the lens in third case. So this is negative here, so they got cancelled here. This 0 got cancelled, 2 zeros got cancelled, and finally it becomes minus 0.8. So this is the overall linear magnification produced by the combination of lens and mirror. And here negative sign shows that the final image is inverted. Final image is inverted. So these are the answers for the given problem. Thank you.